We have actually measured the voltage in this circuit to be V equals 3.86 volts and the current I to be equal to 70.8 milliamps. And the first question is, how good are these readings? Well, the manufacturer's specifications for this digital multimeter rate on a voltage measurement that the voltage reading is good to plus or minus 1.2% plus 2 digits. On a current reading, it is rated as plus or minus 1.5% plus 3 digits. Now, 1.2% of 3.86 is in fact 0.0463. However, since the digital multimeter can only read to the second decimal place in this case, it makes no sense to quote anything beyond that. So I'm going to round that to 0.05 as 0.5 there. And then 2 digits simply means a 2 in the last column, which is a 0.02. And so the total uncertainty in that reading is 0.07, and I can write V equals 3.86 plus or minus 0.07 volts. Similarly for the current, 1.5% of 70.8 is actually 1.062 milliamps, and so again I am going to round that to the last place shown on the digital meter, which in this case is the first decimal place, and round that to 1.1. 1.06 rounds up to 1.1. 3 digits simply means 3 in the last place. That added together is an uncertainty of 1.4 milliamps, and so the actual current I is 70.8 plus or minus 1.4 milliamps. Now to calculate the resistance, R is just V over I, which is 3.86 volts over 70.8 milliamps. But to convert that to amps, 70.8 milliamps is 70.8 by 10 to the minus 3 amps on the bottom line. And multiplying that out, it comes to 54.519 ohms. How good is that value? Well, since I'm doing a multiplication, I can write delta R over R is equal to delta V over V plus delta I over I. Cross multiplying that up, we'll just write delta R equals R times delta V over V plus delta I over I, which is 54.519 times delta V over V is 0.07 over 3.86, and the delta I over I, as long as the top and bottom line are in the same units, that's just a pure ratio. So working in milliamps, that's just 1.4 milliamps in 70.8 milliamps. And multiplying all of that out, we get a final answer of 2.068 ohms as an uncertainty. So what do? We will round the uncertainty, since the leading digits are 2, to 2 places, write it as 2.2, and then round the value to match, ultimately writing the resistance R is 54.5 plus or minus 2.2 ohms, which compares favourably to our last measurement because it is in agreement.